Okay, we're in section 32 now. The material here, again, very consistently told. Whoops, sorry about that. We're going to be discussing how to get to exercise 32. What you need to do is read the contents, understand the examples, and then start working the exercises. My name is Ron Bannon. This is the draft version of Webster Wells's Advanced Course in Algebra, dating back to 1904. This material is being made available to the Prison Mathematics Project participants only at this point. It will be published. It'll be published at a later date. If you need to reach out to me for any reason, my name is Bannon again. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right? So let's take a look at the contents, see what we're in store for. This is going to be solving simultaneous linear equations containing two or more unknown numbers. All right? Now, certainly nowadays we'd say two or more unknown variables, but these variables will represent by numbers. All right? Now, certainly we'll go through examples. As I go through examples, I want to point out the way Wells does things, the way I do things. There are a great deal of similarities. Things really haven't changed much. But the bottom line, you may look at them as being somewhat different. All right? Now, granted, Wells does talk deeply about this problem, and what I mean by that, two equations, two unknowns, and he talks about it a lot. All right, now certainly when I go through the problems, my gut feeling about this over here is that when I do go through the problems, I'll be looking for things to do. All right, things that I like doing. All right, and again, what Wells does, what I do, may look different to you. They're really quite similar, but it may require some thinking. All right, so this is a longer section. I want to get to the examples. As I'm doing the examples, my claim over here, what I'm going to be looking at is I see two equations with two unknowns, and certainly I'm going to claim you can add them together. Right? They're equal, you can add them together. But unfortunately, if I add them together, I'll put a line over here. The only thing that's really required from me is that the equal signs line up to add things together, and they do. What would you get? You get 12x plus y equals 21. Well, that really doesn't tell me much, other than the fact that I got another equation, but it doesn't tell me much. It doesn't know what x is or what y is. So I'm going to erase that. And what I want to do is I want to eliminate something. All right? What I'm going to eliminate over here, I'm looking at it, and I'm going to eliminate the y in the problem. The way I'm going to do that is I'm going to look at those two, and I want to find out the least common multiple between their coefficients. And I'm just looking at the coefficients as being positive numbers, 3 and 4. What would that be? 12. So I'm going to multiply the top equation by 4 and the bottom equation by 3. Let's go through that. Now when I say multiply the top equation by 4, I'm saying multiply every term or both sides. What do you get? 20x minus 12y equals, 4 times 19, that's going to be 40 and 36, 76. All right, let's do the bottom. 3 times 7x is 21x. And then you would get plus 12y equals 6. Then what we're going to do is we're going to add them together. This technique is also called addition technique. But again, some people call it elimination, some people call it addition. All right, so what do you get? You're going to get 41x. The y's disappear, and what do you get? 82. Well, lo and behold, x turns out to be quite a simple number. What is that number? X equals 2. We also need to know what the y is. There's two unknowns in the problem. My suggestion is to do the following initially. Eliminate again. Let me erase this over here, and we're going to do it again. This time what we're going to do is we're going to eliminate the x's. What's the LCM between that? Well, let's write this down. Between 5 and 7 would be 35. So I'm going to multiply the top by 7, and I'm going to multiply the bottom by actually minus 5. The reason being is we're going to add, and if I add these things together, I want to make an elimination happen. What elimination? The x's to disappear. Let's write this down for you. You're going to get 35x minus 21y, and 7 times 19 is 70 and 63, so that's going to be 133. Minus 5 times the bottom equation is minus 35x minus 20y, and minus 5 times minus 2 is minus 10. All right, let's keep going through that. And certainly, I put a little line there to indicate we're going to add them together. And what do you get? Well, let's see, the x's disappear, and the y's will be minus 41. I'm going to bring this over here, by the way. And there you'd get what? Let's see, 123. And now I'm starting to see y is also pretty easy. Y is just minus 3. Okay, mistakes are easy to happen. So what I want to claim is you should check these problems over here. Let me point out what I mean by that. You're going to look at the original. This is the original. There's two equations, and you're going to plug in. Let me go through that with you. I'm going to check. Let's do the x first. What do you get? 10, 14. Let's do the y, which is minus 3. Plus 9, and that's, excuse me, minus 12. What's 10 plus 9? 19. What's 14 minus 12? 2. Well, that's exactly what they said it's going to be. So these are good answers. Again, we provide a key for you, and in the key you'd also see those answers listed. All right? Let's go to the next one. Now, this one over here, I'm looking at it, and again, they're saying, solve for x and y by initially using the method of elimination followed by the method of substitution. Well, let me give it a try. All right, let me do elimination first. They said, initially start by elimination. I'll do that. I'm looking at it, and I'm going to say for me, and again, it's up to you what you want to do, but I'm going to eliminate the x's. All right, now if you ask me tomorrow, I might say, I'm going to eliminate the y's, but I'm starting with elimination. So let me put that down. I'm saying, what's the least common multiple between 15 and 10 would be 30. So I'm going to say 2 times the top equation. That would make it, 30, right? And I want to make the bottom one also 30, but the opposite, so it'll be minus 3. Let me do that. I'm initially starting with elimination. And what do you get? 30x plus 16y equals 2. What am I doing? I'm multiplying every term or both sides of the equation by the number 2. Now let's do the minus 3 now. What do you get? Minus 30x. Let's see, minus 3 times minus 7 is plus 21, right? And then what do you get? Well, 3 times 24, it's a positive number, 60 and 12, 72. Put a little line here. I'll add them together. What are you going to get? Well, let's see. You're going to get 37, right? And what's that going to be? 74. Well, lo and behold, is also pretty easy. Y is equal to number 2. Now, again, I want to remind you what they said to do. Initially, using elimination, and then they said method of substitution. Well, substitution, what I'm going to talk about is taking this, which is y equals 2, and plugging it in somewhere. Now, someone says, where would you plug it in? Any equation you like. I'm going to pick the first one, all right? Plug in the first one, what do you get? I get 15x plus, well, if y is 2, I get 16, right? And that equals 1. What do I do now? I'm doing, that's a substitution, by the way. I'm going to subtract 16 from both sides. I get minus 15. And I'm going to say x equals minus 1 now. So I have an answer. And my answer is y equals 2, x equals minus 1. I don't know if it's right, though. I make mistakes all the time. And what I'm going to do is I'm going to check it. And checking should be very easy if they're integer numbers. I mean, really easy. So let's just check it in the original. This is the original. I'm going to plug in the minus 1 for x first. That's minus 15, minus 10. And then I'm going to plug in the y, which I believe is 2. That would be plus 16. And that would be minus 14. Well, if I looked at that, minus 15 plus 16 is 1. And minus 10 minus 14 is minus 24. Exactly what they said it was going to be. It's working out beautifully. Again, work is put down for a reason. We want you to look at it. But the bottom line, if you're sailing through this pretty smoothly, there's no real reason to look at somebody else's work. All right? So I think I did it the same way. Yeah, I did. Not a problem there. All right. Any method. Oh, no, I'm sorry. Method of substitution. All right. So it says solve for x and y by the method of substitution. And it's problematic. I'll be honest with you. For some students, it's problematic. What you need to do is take one of these equations, any one, by the way, and solve it for one of the letters. Well, I'm going to take the first equation, and I'm going to solve it for x. I'm going to solve for x. What do you get next? X equals 15 plus 9y over 7. Then I'm going to take this, and I'm going to plug it into the second equation. Now, let's put that down. So what do you get? 8y, the second equation, minus 5x Well, what's x? This is what x is. I'll write it down. I think immediately you can see the advantage of using elimination. It's so much easier. I'll go through the work, though. And let's see how I did there. By the way, someone said I'm looking at your work in the blue area and it's different. Well, you know what? One day I do one thing, another day I do another. It's really all equivalent, if I'm telling the truth, by the way. So let's take a look at it. What I'm going to do is I'm going to multiply both sides by 7. And the reason why I want to get rid of the fraction. And 7 times 8 is going to be 56. Now the second term, the 7 disappears. I'm left off with, minus 5 times 15, which is minus 75. And then minus 5 times y, which can be minus 45y. Now remember, we're multiplying both sides by 7. I hope you haven't forgotten that. 7 times 10 is 70, and 7 times 7 is 49. That's going to be 119. Minus 119. Mistakes can happen. We'll figure this out later. So let's see, 56 minus 45, that's going to be 11y. And I'm going to add 75 to both sides. I get 25, 35, 44. Minus 44. Well, what's y? Y would have to be minus 4. All right? Now, what's nice about this, if you know y, you know x. And why is that? It's right over here. Let me write that down for you. That would be 15. We'll check it too, don't worry. Let's see, minus 4, that'd be minus 36, right? Over 7. And what do you get there? That would be minus 21 over 7. So x is minus 3. Let me just circle in the answers for you. Certainly, I'm not going to commit that until I can check it. And don't be confused. I'm checking the x first. And what would you get? You would get minus 21. And then you get, again, I'm looking around. I'm seeing 15 now, right here. I'm going to do the y now, which is minus 4. That would be plus 36. And again, I believe the y is minus 4. That would be minus 32. Well, minus 21 plus 36 is going to be 15. And minus 32 plus 15 is going to be minus 17. It works out perfectly. All right? Again, these answers are being listed for you in the answer key. All right? Just like the other ones. Let me just point that out for you. Remember I said x is minus 1. And I want to make sure y is down there. Oh, y is 2. And I said that there. And let's just go back to number 1, because I forgot to do that for you. I want to say they say x is 2. I see that. And y is minus 3. And you should look at that, at the minimum. Right? If you're really confused, you can look at my work too. All right? So this says solve for x and y by the method of comparison. And I got to mention, that's something that Wells will do. What do? He'll solve each of these equations for one of the letters. This is a method of comparison. Let me write that down for you. And that's going to be the first equation. I'm solving for x. That would be 5y minus 16. And I'm going to continue to solve for x. And that would be x equals 5y minus 16 over 2. I'm going to solve this one also for x. I get 3x equals 5 minus 7y. And then I would divide through by 3. And what do you get? X equals 5 minus 7y over 3. Now, by comparison means I can compare those two now. So what am I going to compare? These two things here. They're both the same. Why do I know that? They're both x. So let's write that down. And I'll write on the side. So I'm kind of jamming it in. I realize that. 5y minus 16 over 2 equals 5 minus 7y over 3. The LCD is 6. I'm going to multiply both sides by 6. And what would you get? Well, let's see. You would get, 2 goes into 6 3 times. So on the left-hand side, you get 3 times, 5y minus 16, which would be 15y. And then what do you get? You get 3 times 16, which is going to be 48. Now, if I multiply the right-hand side by 6, the 3 goes to 6 2 times, so I'm multiplying by 2. 2 times 5 is 10. 2 times minus 7y is minus 14y. What would you do next? Well, I'd probably add 14y to both sides. I know I'm jamming this in, by the way. And it add 48 to both sides. All right, what do you get? You get 29y on the left. On the other side, you get 58. Well, lo and behold, another pretty simple problem. Y equals 2. How would you figure out the x? Plug it in. Where do you plug it in? Right up here. So if y is 2, what would you get? Well, on either equation, whoops, I'm sorry about that. On either equation, doesn't matter which one to pick, the top one would give you what? That would give you 10 minus 16, which is minus 6 over 2, which is minus 3. If you did this one over here, what would you get? You would get 5 minus, well, let's see, you would get minus 14, so that's going to be minus 9 over 3. It's still going to be minus 3. So these are the answers. All right, I do want to go back and just emphasize checking it's probably a good idea, and I'll check it for you. This is the check. I think x is minus 3. This is going to be minus 6, minus 9, and I think y is 2. So minus 10 and going to be 14, right? Whoops. So minus 6 minus 10 is minus 16, as advertised. Minus 9 plus 14 is 5, again, as advertised. So they're the answers, and those answers are also listed for you in the key. That's what your x equals minus 3 is listed as well, all right? Okay, this one, they say solve for x and y, but they're not telling you how. So my gut feeling about this one over here, it just doesn't look right to me. So I want to write them so they look better to me. So the first equation, and again, you decide how you want to do this. I'm just going to say just the first equation. I'd write it so it's a little bit simpler to look at. And someone says, no, I just want to keep it as it is. And I'm not saying you can't. I'm just saying that it may pay off to simplify these things before proceeding forward. So I'm going to multiply the top equation by the LCD. And the LCD would be, x plus 3, y plus 4. And what would you get over here? Again, maybe you're getting a little more experience with this. I hope you are. This would be 7, y plus 4, minus 3, x plus 3, equals 0. Again, the LCD in the top equation is just simply, x plus 3, y plus 4. And that's all I've done, multiply both sides by that LCD. And I'm going to put the bottom equation down. It looks pretty bad, but it looks like x. Sorry, I'm going to get y minus 2. And then minus y, x minus 5. It still looks really bad to me. So I'm going to keep going through it, and one step at a time. So I'm going to multiply the top out. What do you get? 7y plus 28 minus 3x minus 9 equals 0. Let me do the bottom equation. It even looks worse. xy minus 2x, let's see, minus xy plus 5y. Everything's looking really bad. But here's the deal. A little bit of work is going to look nice. What do I mean by that? These cancel off. And what am I left off with? Let's write this down. Really careful, too. The bottom equation is just going to be minus 2x plus 5y is equal to 0. I want to do the top equation, but I want to be honest with you. I want to put it in an order that looks familiar to me, which would be x, y equal number. So I'm going to write down minus 3x, right, plus 7y equals, well, let's see, 28 minus 9 is going to be 19. So it's going to be minus 19 now. All right? So what am I going to do now? I'm looking for an elimination because I like elimination. Now, you can say I like, comparisons. I like substitutions. You decide what you like. I just like elimination. And I'm going to eliminate the x's. And what's that going to be? The LCM would be 6. So I'm going to multiply the top equation by 2 and the bottom equation by minus 3. Let's go through that. And what do you get? Minus 6x plus 14y equals, let's see, minus 38. This is going to give me 6x minus 15y equals 0. I'm going to remind you we're addition technique or elimination. The reason it's called addition, we're adding things together. The reason it's called elimination, we're hoping for elimination. Well, what do we have here? Minus y equals minus 38. I think I made a mistake somewhere. Let's see what I did wrong. Oh, I copied wrong. So I got to go back. Someone says, why do you know you copied wrong? I'm looking at the answer, and the answer is y is minus 1. I was going to say the answer is y equals going to be 38. That can't be right. So I'm going to erase this over here. I'm looking back over my work. And I want to encourage you, too. you look back over, find out your errors, and then correct them. And what I did was I copied something wrong. So I'm going to start to erase those things that I copied wrong. And I don't know how that happened. I really don't. Daydreaming, I can't make an excuse, right? That's minus 13. All right, this is minus 13. Let's keep going. And by the way, if you make one mistake, you may make another mistake too. But anyway, what's nice about an key? I'll look at it eventually, but I'm not going to look at it now. This would be minus 6x plus 14y minus 38. What do you get over here? 6x minus 15y, and that's going to be 39. All right? So I'm going to add it together, and you're going to get minus y is equal to 1, or y is minus 1. All right? Then someone says, how are you going to figure out the x in the problem? Well, I have to go back and do something, and I'm going to look around for the simplest equation. Now, the simplest equation is going to be an equation that I have written down that's easier than all other equations. And just kind of looking at it, I'm going to say this one here looks the simplest to me. It's not the original. I'm saying it looks simple to me. So what would you get? You would get minus 2x, right? And then if y is minus 1, you get minus 5 equals minus 13. I'm going to add 5 to both sides. You get minus 2x equals minus 8, and x would equal 4. All right? Now, I hope you remember that I always said you should check it. If you're a trusting type person, you can trust me, but I don't think it's a good idea. I think you should probably check it. Where do you check it? Always in the original. This is more complicated, but I do want to check it. So I'm going to check one term at a time, see what I get. So I believe x is 4. So what would you get? 7. I'm doing the top equation. 7 over 7, which is 1. Minus, well, y is what? Y is minus 1. So you can get 3 over 3, which is 1. Well, that worked out beautifully. Now let's do the second equation. X is 4. I'll write this down. And y minus 2. If y is minus 1 minus 2 is minus 3. Minus, well, y is minus 1, so it's plus 1 times x minus 5. What's x minus 5? Minus 1. And they claim it's minus 13. This checked out beautifully, by the way. Let's see if the second one checks out. What do you get? Minus 12 minus 1, which is minus 13. It's worked out beautifully. I also want to point out in the key, I'm seeing those answers. All right, let's look at number 6. I want to clear the fraction. How would I do that? I'd multiply the top equation by xy, and I'd multiply the bottom equation by xy. It's going to clear the fraction out. Now, someone said, I don't want to do that. And I'm not saying you have to do that. I'm just saying this could be a possibility. Now, I have not looked at my key yet, and this could be a dead end too. This could be something that makes the problem much worse than it turned out to be. What do you get over here? Well, you get 10. Whoops, sorry about that. Get my eraser out again. Whoops, I did it again. You would get 10y minus 9x equals 8xy. What do you get in the second equation? Well, you can get 8y, right, plus 15x equals minus xy. All right? Now, certainly doing that, I'm going to say it's not bad, but I got a lot of different variables now. What I mean by variable terms, I got one with a y in it, one with an x in it, one with an xy in it. I'm thinking to myself is, maybe that's not a good way to go. So let me erase this and rethink. And this is going to happen to you too. You're going to say, no, this is not working out for me. So what I want to do is I'm going to say, they really do kind of line up. Right? They really kind of line up. What I mean by that, there's a column of x's, there's a column of y's, and there's a column of constants. So what I want to do is I want to get rid of the term with the x in it. Or you might say I want to get rid of the term with the y in it. But as I'm doing this over here, it's still going to be some common multiple to get rid of that term. So I'm looking at what's common multiple between 10 and 8. I'm going to say 40. So I'm going to multiply the top equation by 4, and I'm going to multiply the bottom equation by minus 5. And let's see what happens there. And again, it could be another dead end. So what do you get over here? 40, whoops, let me get my eraser out. You're going to get 40 over x minus 36 over y, and I'm multiplying by 4. This would be 32. By equation by minus 5, that would be minus 40 over x minus, what's going to be 50 and 25, so minus 75. Give me 1 second, I sharpen my pencil. Over y equals 5. Well, I'm going to put a little bar here, indicating I'm going to add this together. And I bet things are going to work out pretty nice now. Why is that? I got this to disappear. And this doesn't look bad to me. What are you going to get? Let's see, minus 111, right? Over y equals 37. All right? So what I'm going to do now, I'm going to solve for y. I'll write it down for you. And again, we hope your algebra skills get a little bit better. I'm not taking time to think about that. And let's see, what would you get? Looks like it goes in minus 3 times, right? All right. So I'm going to say that's not bad. I got y to be minus 3. I'm not saying it's right, by the way. I'm saying it's not bad. So what am I going to do? Well, you could play that game again and again, but I'm going to make a substitution because it doesn't look bad to me. So I'm going to substitute here in the first equation. And what do you get? You would get 10 over x. And if y is minus 3, what would you get? You get plus 3, right? Equals 8. And then what do you get? 10 over x equals 5. And I'm looking at that. It looks pretty easy. X is 2. All right? So I'm going to say this is an answer. I'm not saying it's right, by the way. By the way, I hope you don't get confused with the work. It spilled into this one over here. All right? And that happens to me sometimes when I'm doing my chicken scratch. It surely doesn't happen when I'm typing things up, by the way, because I would never let it, get into the next problem. Let's check it. All right, let's check it. So someone says, what are you going to check? We're going to go back to the original equation. You're going to check nowhere else. And I want to see if it makes any sense. Let me just erase this chicken scratch next to it. How do I do that? Plug it in. Let's do it. So I believe x is 2. So what do you get? 5 and 4 if x is 2. I believe y, is minus 3, right? So that would be plus 3. And this would be what? This would be minus 5. What's 5 plus 3? 8, as advertised. What's 4 minus 5? Minus 1, as advertised. So I'm gonna commit to that now. Y is minus 3, and x is 2. Let's see if they did that. Y is minus 3, x is 2. All right? Now, someone's going to say, oh, your work looks different here. Yeah, maybe it does. All right, the bottom line is you realize that there's a variety of work, not just one path to the truth. All right, let's keep going. Oh, look at that. We're now at exercise. These are the exercises over here. What do we want to do with the exercise? Really the same thing. Now, somebody said, oh, they're throwing decimals at me now. It's no different than fractions, right? No different. All right, this looks very familiar to me. We've seen something like this before. Again, this one solve for x and y, same instruction. Again, you're seeing decimals, you're seeing fractions over here. Where the fraction contains a denominator, has a variable in it. I would use the method we just did. All right? And again, answers are being provided. No work, though. Someone says, oh, there's no work here. You're right, there's no work here. All right? We just went through 6 problems where we gave you the detailed work. They're just answers over here. And it's nice to have answers, by the way. The deal, again, is this, though. You know what? Maybe I made a mistake. If you're doing the problem and you're not getting the same answers as me, maybe I made a mistake. Maybe it's time to reach out to me and say, you know what? You made a mistake on problem number 1 in section 32.3. I would look at it. I would trust that I made a mistake. I would never be so arrogant to say I would never make a mistake. I make mistakes. Over here, again, solve for x and y. It looks tough, but not that bad. And again, answers are listed. This one looks far more difficult. It's a literal equation. It's got an m in it. And, you're treating m and m as some kind of a constant in a problem, and you're solving for x and y or the variables in a problem. They provide answers, but no work. This one over here, again, looks more challenging. That's good, though. I mean, if you're just doing the same old, there's no challenge in life. You want things that look interesting and different to you. This looks interesting and different. But the bottom line, it still says solve for x and y. All right, 6, solve for x and y. Same thing, all right? This might seem tricky to you, and I'll tell you why. You may get an answer. You may think that answer is right, but please, you need to do the checking. You need to do it. Every single problem needs to be checked. right? 7 looks like an interesting problem to me. 8 looks interesting to me. They really do. It's something you wouldn't see in a standard algebra course nowadays. They really give you kind of like really dry, simple problems. Number 9 looks interesting to me. Number 10 looks interesting to me. Number 11 looks interesting to me. It really does. They look like they're going to challenge me, and I like to be challenged, all right? And then what do you get to? You get to this related SAGE stuff over here. What SAGE is? A computer algebra system. That's abbreviated CAS, C-A-S. We actually say CAS. SAGE is free. It's on the internet. You can download it or use the interactive web-based application. And what do we suggest to do? Type in some code, see what happens. See how good SAGE is at doing certain types of problems. Now, again, I realize you may reach out to me. You want to reach out to me. Maybe you want to report an error. Maybe you have a question. I'll try to answer it, all right? I really do. If I'm falling behind, though, I'll be honest with you, sometimes the emails just get so overwhelming, I can't address everyone. I just can't do it. But anyway, my email address is Bannon. That's, sorry about that. That's B as in boy, the @ symbol, NNON.US. And again, I'll try to get back to you. No guarantee, by the way. But again, I really do enjoy reading emails from students or teachers, by the way, that point out errors. All right? I really do enjoy reading that because I like to correct things. I don't like to have errors out there. All right? Again, I appreciate you paying attention, and I wish you lots of luck with this. Thank you.